What's a bag?
Alright, so if you're given an equation and it's in standard form, when you're graphing it, what's the first thing that you would find if you're graphing a parabola? The AOS, the axis of symmetry.
That's this.
So, Cooper, when it's in standard form, the axis of symmetry is what?
Negative b over 2a.
Good. Negative b over 2a.
Yeah.
And then when you're taking negative 2 and you're plugging it into something already negative, it's a positive 2.
Yeah.
So you got what for the axis of symmetry?
1 over
1 over 5. Or you could have written it as 0.2.
5. I did not do that right though.
That's a fraction that divides evenly, so you don't have to round that. So 0.2, 1 over 5. Either one is fine. You're taking 2 divided by 10, which is 1/5. So the second thing that we find then is the vertex. This number here is the x at the vertex. So once you find the axis of symmetry, you use it to find the vertex by doing what? So how would we find the y of the vertex, Libby? Right, so you're going to use that equation, but for the x, you're plugging in the 0.2. Libby, did you get a number there? No. Anybody get a number for the y of the vertex? Dylan?
Negative 7.6.
You're so close. Savannah? 7.3, a little closer.
Negative 7.2.
2, yes. I don't know. Yeah, check to see. Something's slightly up there. Should be negative 7.2 or negative 36 fifths. You can choose to write it as a decimal there because we are trying to graph it then. Alright, so we have the axis of symmetry. We use that to find the vertex. The easy thing to find without doing any work is the y-intercept. Chelsea, what do you use to find a y-intercept?
You just plug 0 in for x and b 0 negative 7.
Yeah, so 0 in for x cancels out, so it's just the negative 7. So 0, negative 7. When it's in standard form, it's always that last number, the c, is the y-intercept. Okay, so we found the axis of symmetry, we found the vertex, we've got the y-intercept. You need 2 other points, and generally to get those 2 other points, we would graph it and look at 2 values on the opposite sides of the axis of symmetry. However, we've also just talked about factoring. We spent 6 days talking about factoring. This is factorable. So instead of picking 2 random points, you will be asked to find the x-intercepts of a standard form parabola. So instead of randomly getting 2 points on the left and the right of the axis of symmetry, this is factorable. And if I want to find the x-intercepts, that means I want to find the values when y is equal to 0. So if I make the y equal to 0, it's just like solving the equation by factoring. So Ethan, if we would factor this, how would we factor it?
7 times 5 is 35.
So negative 35. The 2 numbers that multiply to be negative 35 but add to be
5
negative 2.
and negative 7.
5 and negative 7.
So then we get 5x squared plus 5x minus 7x minus 7. And then you get 5x parentheses,
So 5x parentheses,
x plus 1.
x plus 1.
And you take out the negative 7. Sorry.
Sorry?
And then you get negative 7 x plus 1.
Good.
And then you get parentheses 5x minus 7 parentheses x plus 1 parentheses.
Awesome. Thanks. So again, because we've talked about factoring, you now can take something in standard form and find x-intercepts for it by factoring. So there will be, like the test takes you step by step and it tells you the things that you have to find, but when it's in standard form, you'll be asked to factor it to get the x-intercepts. So the x-intercepts are taking these and setting them equal to 0. So Ethan, if I set each of those equal to 0, what are the 2 x-intercepts?
Well, one is negative 1.
One is negative 1.
And the other one is, wait, hold on. Would it be, wait, my mind is, looks like our ice cream sandwich.
So 5x minus 7 equals 0. So what would you do to get x by itself?
You have to add 7 to the
Add
other side.
7.
And then
And,
you divide 7 by 5.
right,
You get
so
7
7
over 5.
over 5. So those are your two x-intercepts. 7 over 5 is the same as 1.4. Good. So we have everything we need to graph. You don't have to find any other extra points because you're going to end up having 5 based off the information that we have up here. So the axis of symmetry is at 0.2. So you're just making a dashed line to the right of the y-axis, or x equals 0. And then on that dashed line, your vertex is down to negative 7.2. So just slightly below it. We have one y-intercept at negative 7. It is really tiny, especially by the vertex. And then the other one should be on the other side. It should not be at negative 1 or a positive 1 because you're going 0.2 to the left to get to the y-axis, so you need to go slightly 0.2 to the right of the axis of symmetry. They're really close together. And then your other 2 points that we just found, 7 halves is 1.4 and then negative 1. So negative 1 and 1.4. The reason this is so narrow is because of the 5 in front of the x squared. Remember, the bigger that number, the more narrow a parabola will be. So that's why it's so tiny at the bottom. Those points are so close to each other. Any questions on standard form? So if you flip the page over, the first column is standard form. You should be able to fill in all of that information because we just went over it with this problem. So standard form is y equals ax squared plus bx plus c. Chelsea, I will print these out for you then. The line of symmetry or axis of symmetry is negative b divided by 2a. And again, we just went over that. The vertex, the x value is also negative b divided by 2a. The y you need to plug in to find the y. So you plug in x to find y. So at every number you're getting for the axis of symmetry, you're taking that number, that's the x of the vertex, you plug that number in to find y. The y-intercept is found by letting x equal 0, but it's always the c value because everything cancels but that last number. And then to find the x-intercepts, we set y equal to 0 and factor. The extra points in this case are not needed. You only need 5. We don't need another set of 2 points more to get 7. 5 is enough.
Can you go up, please?
Yep.
Okay, yours not? Okay.
So the second form, it says it's graphing form. The other word that we used was vertex form. So if you look at the middle column, the vertex form would go with the middle column. So if you want to label it as vertex and graphing, they're pretty much called the same thing. This is the form where the vertex is in the equation and you're just pulling those numbers out of the equation. So you don't need to calculate an axis of symmetry or a vertex because of the way the numbers are written. So this one had the a and then x minus h plus k. So this is a vertex form where the h and the k were in the problem.
Oh, I remember this one.
So the line of symmetry is just x equals h. Remember, if you want to remind yourself, it's the opposite of what you see in the parentheses, because that minus sign isn't attached to the h. It's a minus sign as part of the formula. So if there's a minus in the problem, really the graph is shifting right. If there's a plus in the problem, really the graph is going left. So it's opposite of what you see in the parentheses. The vertex is h and k, so no calculating necessary. The y-intercept, you need to let x equal 0 to solve or find y. So in this case, if I replace my x with 0, I would have 0 minus h squared plus k, so I would be able to then find my y value. So you're making x 0 and then pretty much breaking the problem down to get y. The x-intercepts we won't be able to find when it's in this form. We could use Ethan's NA.
Oh yeah.
Yeah.
A.
So we won't get x-intercepts in this form, but we will find those 2 extra points by making that t-chart and picking 2 points on either side of the axis of symmetry. So use 2 points on either side of the axis of symmetry. So we don't get x-intercepts when it's in this form, but we will get those 2 other points by looking at the axis of
Like
symmetry.
-3 and 1?
Like -3 and 1. Whatever they might happen to be.
Oh.
Alright, so the last form is intercept form, but intercept form is really the factoring that we've been working on. So every problem that you've done in the last 6 days since last Wednesday, 7 days, has been in intercept form. When you factor, you're really taking an equation and writing it in intercept form. So factored form, intercept form. It means your answer should have 2 sets of parentheses. So that's intercept form, that's factoring.
Actually, graphing might be my favorite form.
So to get the line of symmetry, you take the P and the Q, and you cut them in half. And remind yourself, again, it's the opposite of what you see in the parentheses. But the x, the line of symmetry that x equals should be in the middle of your 2 x-intercepts. For the vertex, the x value is that P plus Q divided by 2. Whatever your axis of symmetry is your x of the vertex. And then again, to find the y, you have to plug in x to find y. So you're taking the axis of symmetry, you're using that number, you're plugging it in to find your y value. The y-intercept, again, we need to let x equal 0. The only time it's actually in the equation is when it's in standard form. So then I would have 0 minus p, 0 minus q. Then we get an answer for y. And then the last thing here, the x-intercepts, well, that's the form that it's in. So the numbers, I've got an A here. The numbers in this problem are the x-intercepts. So when you're factoring it and you're solving, anytime you solve for x, you're really finding an x-intercept of the graph. So the x-intercepts are the p and q values in your factored answer. So whatever you get when you solve those parentheses would be your x-intercepts. And again, the extra points are not needed. So if you get x-intercepts, you don't need to find those other points. So the goal for this sheet would be and as you work through some of the problems on the study practice homework, or the review for the test tomorrow, this sheet hopefully will be helpful for you to look at and say it's in this form, so this is what I need to do. Questions? So I'd like to look at the homework. As I was walking around, a couple of people were saying, can we go over this one? Let's look at that one. So if you look at the homework assignment, number 8, the answer key was wrong. So if you were using the answer key for number 8, it's not right. There was a little answer sheet. It was that little quarter sheet of paper, Cooper, remember?
Oh, that one.
Oh, that one.
I remember that.
So, looking at number 8,
Project baby. Oh, I got it right here. A little. Oh, you said quarter sheet?
Yep.
You said quarter sheet? Not that too.
All right, so what would you take out for number 8? What's the GCF, Brandon?
3.
A 3. So when you take out a 3, Brandon, what do you get?
3 parentheses 4x squared minus 8x minus 3.
And then if you try and factor it, because it looks like you should be able to factor it, we would take 4 times negative 3 and get negative 12. And it looks like negative 6 and negative 2 should work.
Nope.
But they don't.
But they don't
Because it's double
because,
negatives.
yeah, you've got 2 negatives there. And that needs to be a plus sign in order for it to work. The answer sheet, though, the book's answer sheet, not mine, has it wrong because they, I don't know, whoever made that answer sheet, I guess, just forced it to be a plus sign. So it is factorable, but this is all you can do to factor it. It can't be factored any further.
I don't know why I wrote that the right ones were 4 and 2.
I'm just kidding.
Any questions with number 8? All right, so then if you go down to number 22, look at number 22. Number 22 is factorable. It's one of those special patterns.
I did it.
Perfect square binomial. So this factors as 3x plus 2 and 3x minus 2. Because you're taking the square root of 9 and the square root of 4. So it does factor as a perfect square binomial. And then you solve each of those. So you get a negative 2/3 and a positive 2/3. Number 12 was not factorable as well. Number 12 didn't work because the 5 isn't a perfect square. So that's why 12 wasn't factorable.
What is 4?
4? No, 4 was not factorable as well.
Because it got that double negative. Yeah. No, it doesn't. Never
All right, so if you flip it over and look at 34, why isn't 34 factorable?
I thought it was 1/2.
What?
They are perfect squares because you can take the square root of 4, you can take the square root of 1. Brandon?
Because for the perfect square binomial to work, it has to be a 4x squared minus 1 instead of a plus 1. Because if you try to do it as 2x plus 1 times 2x plus 1, you will get regular x values in the middle, and that's not what the original
Right.
equation is.
So the original formula, so if you like look at the little half sheet with all the patterns on it, it has to be a minus 1 in order for you to factor it. That's a plus 1. So yes, they're both perfect squares, but the plus sign right there means it's not factorable. You cannot break it down. So if you did factor it and you FOILed what you had, you'd end up with that middle term, that bx term. So that one doesn't work. Any questions on those? So when the directions tell you to find the x-intercepts by writing it in intercept form, that just means you have to factor it. Now yes, when you're factoring this, you're multiplying 25 by 24. You get a really large number. You're going to have to use your calculator to try and break that down. So no, there wouldn't be anything quite that large on the test, but like if there was a number like 288, that's definitely doable where you'll have to multiply and see if you can figure out some numbers there. All right, so I want to look at the picture frame problem.
I never did these.
You might want to circle this, redo it tonight after we go over it, or look on your book on page 264 and do a problem on page 264. But there will be a word problem very similar to this setup, or very similar to like the one that we did yesterday in class where you were putting the number of bikes together with the fact that you would sell 3 less bikes if you do that price increase. Definitely a word problem on the test, very similar to the ones that we did yesterday in class. So you're making a picture frame with uniform width. The picture is to be displayed at the local museum. It's 3.25 feet tall and 3 feet wide. The museum has a total of 15 square feet of wall space to display the picture, and we want to use all of the space. So the first thing, if you look at the diagram that's already drawn for you, the current height of it, or width of it, depending how you want to look here, is 3.25. But if I add a picture frame to it, that picture frame goes around the entire picture, so I would have an extra x on each side. So that would be my 2x, plus the initial 3.25. So that describes the one side of the picture frame. So x plus 3.25. To get all of this, I have to add all those together. So for my length, I have to do the same thing. I have an x plus 3. So we need to add those together. How much space is allocated for this entire picture? 15 square feet is my total space that we have to take up. And we want to use all of it. So I can set that equal to 15 because all of that, this entire at 2x plus 3, 2x plus 3.5 represents the entire space that we need to take up on the wall. So how would I start to solve this? Foil it. So you have to FOIL first. So we've got 4x squared. And then what's the middle term? 12.5x. And then the last term. So 3 times 3.25. Savannah? 9.75. So if we solve this, we have to set it equal to 0 to solve. So now it's equal to 0. We have to take 15 to the other side. And 9.75 minus 15 is negative 5.25. All right, so there's a trick to this problem. And on the assignment sheet, Nina, you have your assignment sheet right there.
Yes.
What does it say for number 37 on the assignment sheet?
Multiply by the LCD.
Multiply it by the LCD first. So prior to factoring it, if there are decimals or fractions in the problem, you could multiply it by something to get rid of the decimals or fractions. So if I have a decimal of 1/4 and 1/2, how could we multiply it by a number to get rid of them? Nina? Multiply it by 4. You're allowed to do anything to any problem. You can multiply it by things, you can or divide it by numbers, as long as you do it to both sides. So if I multiply the right by 4, I need to really multiply 0 by 4, but we know that doesn't change the 0. So that leaves us with 16x squared instead of 4x squared. What's 12.5 times 4? So 50. And then 4 times negative 5.25 is 21. Now, unfortunately, if you have a 16, a 50, and a 21, they don't have a GCF, so this is going to be a larger number. So 16 times negative 21 is what?
Negative 336.
336? Okay, I'll just rewrite it. So negative 336. So using your calculator, it's a little bit of guess and check, trial and error, but you need to figure out two numbers that multiply to be 336 but add to be 50. Julia?
56 and negative 6.
Great, 56 and negative 6. And then you're factoring it like usual. So 16x squared plus 56x minus 6x minus 21. 16 and 56 have what in common? 8, yeah. And then that would leave us with x plus 7. 6 and 21 have a negative 3 in common. Nope.
It'd be 2x.
2x plus 7, thank you. So that would be a 2x plus 7. Thanks, Chelsea. So we would have 8x minus 3 and 2x plus 7. So if you solve each of these, you get negative 7/2, which we can't have a negative. You get positive 3/8. That's 3/8 of a foot, which is 0.375 feet. Or, does anybody know how many inches that is? If you take 0.375 times 12.
4.
Yeah, 4.5 inches. So that's the picture frame. So think like you have a 4-inch picture frame going around the picture that's already there. So that's a nice size picture frame. Yeah. Questions?
That
Brandon.
tiny.
I wanted to
Yeah,
accidentally wrote 50x minus 6x instead of 56.
Ah, yes.
It's tiny.
Okay, so you have 10 minutes. I have a book up here. There are 6 books over there. You can take a picture of page 1013. I'm going to hand back quizzes from yesterday. I'm also going to hand back your homework I collected. But please start working. You should have grabbed graph paper. There's 6 problems you'll be graphing. There's lots of factoring problems for you to try and practice. This is collected, so I will be looking at this. It's not an optional assignment. And Chelsea, I will go run next door and get yours.
Okay, thank you.